UPS came bearing gifts today, guys. So this is the cam kit and the rotating assembly for the 390 Ford. Actually the 431 stroker Ford. So we're gonna open this stuff up and check it out and see what we got. Alright, so let's take a look-see. I believe this is the cam kit from Michael's engine. Alright, there we go. Competition cams, very nice. Get it out of here. See what we're working with here. We don't need that anymore. Okay, so the kit that we ordered comes with basically everything you need, and I would recommend you do this when you're going to build one of these engines. So we've got the good valve stem seals, the Teflon seals. We got the hardened spring retainers, the keepers that go with that, and these are 10-degree keepers. The stock valve keepers or valve locks are 7-degree. 10-degree is a more aggressive angle, and it's a lot better for a performance engine. So we've got our hardened steel retainers, our keepers, our valve stem seals, and then of course the springs. This is our valve spring set that came with it, and these springs are matched perfectly to this cam. And they give you the specs on the springs and so forth, because when we do the heads, we're going to have to set up the spring height and all that, which is when we get into the cylinder head rebuilding, we'll talk more about that. We have the lifters, of course, and what you'll notice on the lifters themselves is these lifters come in sets, and they have a bar that's attaching them. That bar is an anti-rotation device, and what that does is because this is a roller cam, it has a hardened steel roller down here. The roller has to be held in line with the cam, and so we have an attaching bar here, and they come in sets of 2. And so there's your FE 390 roller lifters, really nice. We also, with the kit, were able to get the billet timing chain set. So this is our set that we're going to run on the front of this engine. And then, of course, we have our cam. Now the camshaft, let's talk about this cam for a minute here. The cam specs are right here on the cam. This cam it has a lobe separation of 110 degrees, so it'll have a fairly smooth idle. It has a valve lift of 529, and the duration at 50 is 218 on the intake and 224 on the exhaust. We like a little more exhaust duration for a torque engine. That gives us a little more, gives that exhaust port a little more push to it as far as getting the exhaust out, and it helps the low end torque. So this is definitely a good torque cam we've got. The camshaft always comes with a cam card, and they gave us a new forged steel pin for locating pin. And the cam card's important. We're going to degree the cam once we get it in, so we make absolutely sure that it is the correct cam, because sometimes, you know, these cams could be misboxed or you know, just something could be wrong. So we want to make sure we degree the cam and make sure it is what they say. This is a forged steel competition cams FE 390 cam, and we went ahead and went with a roller. We're going top notch with everything on this engine. So that's your cam kit, and we'll get back to a lot of this later, but I just wanted to kind of open this up and make sure everything was here and make sure it looks good. And as usual, competition cams, they never disappoint. Their stuff is top notch, and that's kind of why we went with them. So that is your cam kit. Now let's get into the Scat rotating assembly. All right, so here's our pistons and our connecting rods for our FE build. These are our pistons, and what we did on this is we went ahead and we went with a lightweight stroker piston and this is a coated skirt 390 FE Mole piston, and it's forged, of course. We're going with all forged components. Now we went with the dish on this, and the reason we put the dish in this engine is because the way that we figured our compression ratio was with the heads that we're using. In order for this truck to be pump gas friendly, we really couldn't put a flat top in here. We're shooting for about 9.5 to 1 compression. One of the things that we're going to have to do is we're going to have to get this rotating assembly balanced, and I'll talk to you about that here in a little bit. Another thing we have to do is we're going to have to mock up the engine, because we don't know where the deck height is, so we may have to end up decking this block to get our height right. Very rarely does a factory engine have the same deck height on every cylinder, so we may have to correct that on the milling machine, which is, I'm thinking we're going to have to. But as usual, this is a Mole dished forged piston. Again, top-notch quality. These guys never fail to impress me with their stuff. So that's our pistons, and it's like we got a whole set of them there. They also came with the rings. The rings are in here as well, and so these are our ring packs. And we have real thin ring technology. These are the real thin rings. If you know anything about piston ring thickness, thin rings are much better. They're far superior to the thicker stuff we used to use. We have better sealing against the cylinder wall. We have high quality ring materials that can stand up to heat very well nowadays. So that's our pistons, and then of course this is kind of what we were waiting for on this kit. The supplier called me a couple days ago and they said, hey, we're waiting on the connecting rods. I said, well, what do you mean you're waiting on them? They said, well, Scat's making them. They're making the rods for you. So we've got a really good quality stroker rod here. So this is our connecting rod that we're going to be using in the FE motor. It is an I-beam rod, but it's a Scat high performance forged connecting rod that's been completely prepped and ready to go. And of course it's a full floater, has the bushing up there. And so this is the jewel that we're going to be using for this 390. Really nice stuff. All right guys, so we got our crankshaft here from the 390 FE, and this is a Scat crank. It is a cast steel crank. Now keep in mind, we didn't go with a forged crank on this thing, and basically we really didn't need to for what we're doing here. Back in the 60s and 70s, the factory had a bunch of forged cranks from the factory. The reality is that these newer cranks that are made by Scat and some of these companies in the cast steel form are actually stronger than the factory forged cranks. They can handle more horsepower. The forging technology, the material is much more advanced than it used to be. So these cranks are capable of handling 500 plus horsepower without any problem at all. So this is what we went with. We went with what's going to work. We talked earlier about the forged 4340 connecting rods that we have, the piston and pin assemblies, the rings. So let me talk to you about balancing a little bit. So what we did is we've got this engine, we purchased it in an unbalanced form. What that means is we're going to have to send this out and have it balanced. So balancing, basically, this is what it is. What the balance shop, and I have a good friend of mine that really does, he owns a machine shop. He's got a really nice balancing machine. He does a great job. So we're going to send this to him. This is what's going to happen with balancing. He's going to put the pistons on a scale. Now this is a very sensitive scale designed for measuring engine parts. This scale is going to weigh the pistons down to about within 1/4 gram of each other. Now, to give you an idea of what we're talking about weight-wise here, a gram is about the weight of a dollar bill. So imagine taking a dollar bill and cutting that dollar bill into 4 equal pieces. One of those pieces put on the scale is 1/4 gram. That's how closely these are going to be weight matched, or they need to be for an engine. This stuff out of the box, and you can buy balanced rotating assemblies that are pre-balanced. We chose not to do that because I have a balance guy that I trust, and he does really nice work. If you buy it pre-balanced, You know, I've seen them out of the box 3 or 4 grams out, and I just know I can't do that. So we're going to get this balanced. What they do is they put this on the scale and they weigh the pistons. They find the lightest piston out of the bunch. They weigh all 8 of them, and they find the lightest piston of the 8, and they use that as their reference. They put the other pistons on the scale, and then they start shaving material off of these pistons right here, just very gently shaving some material equally off of the pin boss area. You never want to take material off of here or anywhere else on the piston. This area here is actually designed and built into the piston with the idea that you're gonna remove some material here. These are called the balancing pads. So he's gonna shave material off of each one of these pads until all the pistons weigh exactly the same within 1/4 of a gram, 1/4 of that dollar bill. Then he's gonna take the piston pins that go in there and he's gonna do the same thing. He's gonna weigh all the pins on the scale, and we're gonna shave this edge of the pin slightly. They have a machine that has a square grinding wheel, and we just shave this. It doesn't take much usually, they're pretty close. We make all the pins weigh the same. Then we're gonna take our connecting rods. Now the connecting rods have 2 different types of movement here. Down here we have rotational movement, and up here we have reciprocating movement. So they're gonna weigh the big end and the small end separately. First of all, we're gonna hang this on a hanger, and they're gonna lay the small end on a scale. They're gonna find the lightest small end, and again, that's gonna be the reference rod. Then we will start shaving a little bit of material off the other rods here. This is our balance pad, until all the small ends weigh exactly the same. Then they're gonna flip it around, they're gonna hang the small end, and they're gonna set the big end on the scale. Again, lightest rod, then they're gonna shave material off of the heavier rods here. Now we have all of the rods weighing exactly the same on both ends, so the total rod weighs the same. That is the process of weight matching or balancing. Now we have a piston and rod assembly with its pin and its connecting rod. We have all these parts, and they weigh exactly the same. We're going to take this whole 9 yards here, and we're going to set this on the scale. They're going to weigh all of this. They're also going to add the rod bearings in here, and we're going to add the rings on here, because we want to know, because the rings and the rod bearings have some weight. Once we get the total weight of the piston and rod assembly with the piston, the pin, the connecting rods, 1 set of rings and 1 set of rod bearings, now we have a weight, right? We have a number. This is our bob weight. So the bob weight is actually what's going to be hanging out off of this rod journal here. In fact, there's going to be 2 of them. So we take that number and we double it, because each one of these journals here has 2 connecting rods on it. We put the crankshaft in a machine called a computer spin balancer. Now they have soft jaw V-blocks that go on here. They clamp them onto the journal, and then we have stackable weights that go on there. We take our bob weight and we bolt on the soft jaws, and we stack weights on there and secure them on there until we get the exact amount of weight hanging off of this journal that we had when we measured or weighed our piston and rod assemblies. Take the crank, we put it in the machine, and they spin it. And what the computer is looking for, it's looking for imbalances between these counterweights and the piston and rod assemblies out here. Now we bought this crankshaft in an unbalanced condition. So a lot of times on balanced cranks, you'll see holes drilled in this. The reason they drill holes in here is because they're removing weight. Most of the time on a stroker engine especially with these cranks, they make the crank a little beefier than it needs to be here. And they add some weight here because they know that when you balance, it's easier to remove weight than it is to add weight. So most of the time on these Scat kits, they're going to start drilling some holes here in specific spots to remove weight from these counterweights. So hopefully that makes sense. Now, in the event that the piston and rod assemblies out here were heavier, right, than this, what they're going to do is they're going to drill a hole through here, and they're going to press heavy metal into here, and then probably tack weld it in or weld it in. Or they drill it and make it a press fit. Mallory metal or metal that's way heavier than the crank, they'll press it in here to add weight to the crank. because we have to equalize this weight. This rotating mass of piston and rod assemblies out here has to equal the amount of weight over here. So hopefully that makes sense. So that's one of the things we're going to do. So the balance job is going to get the crankshaft, all the rods, all the pistons, all the pins, one set of rings, and one set of rod bearings. We're also going to send with the rotating assembly the harmonic balancer, right? And the flex plate. I haven't purchased it yet. I'm going to get it probably on Tuesday because Monday's a holiday. I'm going to go buy a flex plate for this engine, and we're going to send this whole 9 yards out to the balance shop. So hopefully that makes sense. And I know I've got some of you that are asking questions like, hey, what happened to you? You fell off the edge of the earth. No, I didn't really. It's just that we were waiting for this rotating assembly. I waited almost 2 weeks for these connecting rods because Scat had to actually make these for us. They were out of stock on them. So you get just remember, you guys, this stuff is really time consuming. You know, sometimes you're waiting for parts. This whole 9 yards has to go out to the balance shop, and I'll be honest with you, as busy as he is, it's probably going to be a good solid 2 weeks before I get this balance job back. That's just the way things go in this industry. You know, it's time consuming. It doesn't take him 2 weeks to do the job, but you know, he might have 30 other jobs ahead of me. He's a busy guy. So when I take it down there, it goes in line behind whatever came in first. That's just the way it works. So I've got a lot going on here. Just please be patient. And keep in mind, this stuff is really time consuming. One 30-minute video, not this one so much, but when we're doing actual work, one 30-minute video probably takes 5 or 6 hours of worth of preparation, work, and editing. So it's a lot of work. Putting together a good solid 30-minute video with good content is almost like a full day's work. It really is. So there's a lot that goes into this, and I appreciate your patience. So yeah, I mean, but I wanted to give you an update on the 390. We got the parts. They look great. It's real good quality parts, and this is going to be a very nice build. We also got, I have a lot of other stuff going on, man. I got a 5-liter V8 Mustang engine out of like an 89 Fox body that we're transplanting into an early 68 Mustang. I'm not going to do a complete video series on that build, but what I am going to do is I'm going to do some videos that kind of walk you through some of the changes that you need to make and the things that you need to add or delete from a late model fuel injected motor to stuff it into like a 68 Mustang or something, you know, or your old 70s pickup truck, whatever. So there are some differences in those motors, and there's things that you have to change: the dipstick location, the timing chain cover, the oil pan. We are going to run the factory fuel injection, so we're using the entire you know, GT intake and fuel system and everything, and the computer on the car. So it should be a pretty cool build. But again, there's some non-essentials there. Also, the 351 modified is still on the list to be done. The 502, I still got to get the upper end on that and heads, and I haven't totally decided what heads. I think 781s. I kicked around aluminum heads for a while, but I think we're going to go with the 781s just because it's going to be a tow monster. The LS build. The LS build's coming up. I'm probably going to be doing a disassembly. Honestly, the balance job on this is probably going to be out for a couple of weeks. So, like I said earlier, so I'll probably at least get into the teardown on the LS motor here pretty soon. So there's a lot coming up. I appreciate your support. Go to my Patreon site and support this channel. This stuff's expensive, and I thank you for your patience. I promise you this stuff will get done. It just takes a lot of time. So if there's, and you know, a lot of people go through and they might watch 20 videos and they think, oh, that was so simple, you know, 20 videos. Well, if you watch 20 videos that I posted like in the past year or so, keep in mind each one of those videos is, you know, a full day's work to make. So if you're caught up to this point with all the videos, you know, the videos aren't going to keep coming out like, you know, boom, 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 boom. There's not going to be 10 videos posted in, you know, a week. It's just not feasible to do that. So I thank you for watching, and hopefully this update intrigues you. If you have any questions or comments, ask below. The Scat kit that we bought is absolutely flawless. The parts look great. They did a great job as usual. And if you need to know the name of the supplier where I got this stuff, just let me know. I can give you their name and contact information. They've always done a really great job for us. They're from back east, so everything's shipped here, but I have zero issues with them. Thank you for watching, and I will talk to you very soon, I promise.